The two webinars we're going to do on the 2018 release. I'm going to go over some what I call system enhancements and general items in Mastercam 2018, and then we'll go over a little bit of the design side of Mastercam, so that includes solid modeling and drafting, and then I'll get into more of the meat of it, which is the Mill 2D, and then finally get into the Mill 3D enhancements. And then the other topics will be covered in the one that we're doing the week after the Wisconsin Tool Show, that's next week. If any of you guys want to go, I think it's still free to register. So it looks like most everybody's here and ready to go. So let's get started with the content. So 2018. So a lot of you, and I'm going to launch a poll right now on what version everyone's using. So let's launch it here. It's going to pop up on your screen if you get this answer real quick, just so I can get an idea of what people are using in the room here. But basically 2017, we did basically the third iteration of the Mastercam interface. We had the interface from basically Mastercam version 1 that came out in the 80s through version 9 that ended in the late 90s into the early 2000s, and then we had the X interface that ended last year with the release of 2017. So it looks like a good portion of you have already answered, and so I'm going to close the poll. So it looks like we're about split between 18 and 17, and then a handful of people on X9. So 2017 was the big jump in the interface, and from our experience, it seems like it was a bit easier of a transition than it was going from 9 to the X interface. I think we did a pretty good job of the ribbon bar format. And sorry, I forgot to silence my cell phone. And so now that we got the interface stuff out of the way, 2018, we really wanted to focus on 3 key areas here. And one is performance. How quickly can you get your job done, are the toolpaths calculating faster, are graphics rendering faster, all that sort of stuff. Visualization, a better feedback in the software on what command you're trying to do. You'll see us, especially in kind of the first half of this webinar today, how a lot of that visualization stuff, once you start using it in 2018, you just start taking it for granted. And then the third part is usability. So, getting around the software, being able to perform the function you need to do your job quicker and easier. So, and as with a lot of this stuff, let me get to the next slide here. Mastercam actually helps us out now and kind of prepares a template for the PowerPoint for this. And, it starts out at about 400 slides. And I pare it down. So I have this what'snew.mastercam.com there on the screen. And if you really want to dive deeper into everything that was changed in 2018, I certainly invite you to go to that website. And it's all broken up by category. And depending on the topic, there's videos and examples. And there's also a PDF that installs with 2018 that if you prefer to read it that way to find out what's new. So just some general system enhancements here. We finally added the option for a default file open type. So, if you work with Step or SolidWorks a lot, you can default that, or you can default it to just general Mastercam files. You should be able to see on there. So anything that starts with .mc, you can open up. When you window select now in Mastercam, it's a fairly minor thing, but it's proven useful for me as I've been using 2018, is there's a shading to the window selection, so you can be a little more precise as you select geometry in the graphics window. And then for those of you that are still using X9, the command finder is now just part of the software. It was originally a C-hook in 2017, and a lot of people end up not taking the time to install a C-hook, which is a little add-on program that you can put into Mastercam. And we have an open API where people can develop other programs, but it's now on the Home tab, and think of it as a live Google search. So my example there is modify. So any command in Mastercam that has the word modify in it will pop up there, and it'll tell you the tab and group that it's in the ribbon interface. And if you double click on the particular command, it'll take you right to that command. So if I were to double click modify feature there, it would take me right into that command right inside of Mastercam. So as you get used to using the new interface, it can be an easy way to get around, struggling trying to find the command that you maybe had a shortcut for in X9 or similar. So I'm going to see how these videos show up on the webinar. They're not always the best, but those of you that have used full-blown CAD systems like SolidWorks or Inventor or Pro-E or something like that, we've added additional default view supports. This mainly helps for people doing multi-axis and mill turn type parts where you have the isometric, reverse, and trimetric and views like that, but just a small enhancement for a view support that we probably should have had for a while. So I can't do a raise of hands like I did in the in-person rollouts, but every time I ask if people are using view sheets, I get maybe one person in the room that is using them. And I can't stress enough how useful they can be, because you can basically set any command you want in Mastercam as far as the setup is concerned to a view sheet. So your planes, colors, levels, entity attributes, what view you're oriented in, and so forth. And like anytime I get in a horizontal machining file, I'll set up my B0, 90, 180, and 270 as view sheets. So as I click between them, I don't have to worry about what plane I'm in. I know that the plane's going to follow my view sheets, and then I can bookmark them so that they're saved in those views. But in 2018, we've simplified the creation of them a bit. So they are on by default when you install 2018. You can turn them on or off on the View tab. But when you create a new one now, it pops right into creating a name for that particular view sheet. And it works more like how tabs work in Excel, where the old interface was a little bit not as user-friendly as it is now to create and name and save them. So bounding box, we had a bounding box, I believe, back in X9. I use it a lot just for stock setup or creating containment wireframe for the entire volume of the part. But we added some additional options in there based on user request. And that's something I haven't mentioned yet either is, as a lot of you probably know, but some of you may not, Mastercam's still a small family-owned company out of Connecticut. I think there are about 175 people now. But if working with us, any feedback that you give directly to us or Mastercam, there's a good chance that it can get implemented in the software if it's a good idea or something that's feasible to do. And you'll be given basically a request number for when it could possibly be added into the system. So this was actually one of our customer requests up in Wisconsin that was working with large parts, and they wanted to know the center of these faces where they were creating the bounding box and then having to draw wireframe to get that point. So it's just a small addition in there, but I left it in here because it's a good example of, an email a customer shot me a year ago, and, it's in the software 6 months later. So analyze along a curve. If any of you wanted to do this in previous versions of Mastercam, you basically had to draw a reference geometry and then break the entity and then measure that broken entity. Where now if you're on any curve in Mastercam, whether it's a regular arc or it's a spline curve, you can basically select it via these red and green arrows, and it will, or red and green dots, I should say, and pick up any distance along a curve that you want to measure. And the analyze function also, when you were in lathe, it would always display it as, I believe, X and Z, or maybe even X and Y. But if you are one that works in D plus Z plus, the analyze function does support those values in lathe now, which can save you some time when you're trying to figure stuff out. So the levels manager, we've added support in here, and this really can help if you want to standardize across the company. So if you can see in the video there, I have my model geometry, surface geometry, stock, vices, fixturing, anything like that. I can set up basically a default template in Excel or anything that can create a CSV file, drag and drop it into 2018, and it sets that up, and then I just have to move the items inside of Mastercam to the levels I want. So if you get that sort of standardization, so then if you open up another programmer's file or a file that you worked on months ago, it'll be easy for you to navigate what material is on what level in the particular file. And it's just as simple as taking that CSV file and then dragging and dropping it into that levels area on the screen there. So setup sheets, we added these a while ago. We do have some samples on our website. If you go to shopware.com and then application support and then downloads, it's the same password to download Mastercam 2018, which is ShopWare 2018. And they're fully customizable. It works off of a crystal report style interface. But for 2018, we added a couple enhancements. It now supports all image types, where before it was just BMP format when Mastercam would take a screenshot, and that would create larger files than probably would be needed. So the actual PDF that you'll export out of the reports manager now should be a lot smaller. And also, if you're using the view sheets that I was talking about a few minutes ago, it can automatically create screenshots of those different views as part of the setup sheet. So depending on if you're working with travelers or paperless, it can really help on setting up for what the guys on the floor need to do. So that was it for the system enhancements. We're going to start getting into design solids and a little bit of drafting in here for 2018, and I don't see any questions yet, so we can stay on time. Let's keep trucking. So some basic enhancements for design is we now have solid face color masking, and I'll get into that in a bit in an example I have. But you can basically select solid faces by color if your engineer is designing faces for given colors, or your customer puts critical dimensions in for those. And I accidentally skipped ahead here. We also have now, when you're creating lines, you have the midpoint option. We always had the 2 endpoints or the multi-line option, but this was another user request. They always want to draw based off of midpoints of lines and then trim them up later, and so that's in there now. We also enhanced the transform scale command a bit. So you see those 2 little rulers that are in the red box there. Is, a lot of us probably know what the conversion is from inch to metric, but you can basically click those rulers now, and if you hover over them, it'll tell you which one is inch and metric. And then there's also a little calculator box there if you want to do a different conversion factor. And I had a bunch of slides on this, but I realized it took a while to go through, and I don't know how many people are actually using it in Mastercam. But my best piece of advice here is if you are doing solid sweeps in Mastercam, is to try it out in 2018. Because if you've ever done solid sweep before in Mastercam, it was kind of a guess and hope sort of scenario on if you were getting the correct geometry. And they've enhanced that for previewing what the sweep's going to do. And they've also done a lot with just how the sweep function works in general, and has a lot more control that gets it more on par with a traditional sort of CAD system. So this is part of what I was talking about in the beginning as far as visual feedback in Mastercam. Anyone that is used to doing roll, unroll in Mastercam, you kind of set the roll you wanted and maybe the diameter, and then say okay, and then hope that it was what it wanted the result that it wanted to give you. But now in 2018, any of the commands that we move over into that left-hand side, what we call a panel interface, it gains a lot of functionality in the system, in that we get live previews of the function, and any adjustments you make to it will show right away, what my angle is in this roll example, and what my diameter of the roll is. But really any command that we move to that interface, which ideally it'll all be moved over there as we work through it and the interface update, but roll unroll is one of them that got that enhancement for 2018. So one of my first examples where we'll actually get into Mastercam here, but we added whole axis a handful of versions ago. But one of the biggest feedbacks was if I got a file from a customer where the normals of all the holes were all over the place, I had to individually click through every hole to make sure that the orientation was correct. Because this is a very handy feature for if you're doing 5-axis drilling or just drilling a lot of holes, or maybe trying to create a plane off of a cylindrical feature, because you can create wireframe with the whole axis and endpoints, and you can extend the lines up and down. But if I hop over into Mastercam here, I have my example that you saw on the slide there. But if I go to model prep, and then it's the first button to the left here called whole axis, and I say whole axis, and then you'll see that this little tan box, I can control click to select all faces with matching diameter. So I'll pick one of those holes, control click, and then you'll notice my model kind of flipped around. Now these are kind of all in the same direction, so I could just flip them the other way. But the main option we added here is called orientation, and it's either first pick or I can do C-plane. So if I switch it to C-plane, it's basically going to force the direction of the holes as close as possible to what my current world Z is. So if you see my gnomon here in the bottom left-hand corner, I have the X, Y, and Z axis, and it pushes all the holes in that particular direction. So it just makes it really easy to then go ahead and create all that geometry I need to do the function I was trying to do. And moving along. Oh, there's also an option here if there are blind holes in the file as well, which we didn't have that in 17. So wireframe curve creation. So a lot of people have used silhouette boundary in the past to create containment boundaries for 3D toolpaths or 5-axis toolpaths or a lot of other functions in the software. But we've added a new option that I think a lot of people could take advantage of. So when you created curve on all edges in the past, you basically had to manually click through what you wanted or window select. You didn't really have what I call the model prep selection enhancements that we've added since we've added those model prep functions inside of Mastercam. And let me show you guys a little bit how that works. So let's open up the file here. And if a lot of you don't know, in 2017, you can just drag and drop the file right inside of Mastercam, and it'll open up. So I have this is a pretty simple file here to demonstrate, but I think you guys will get the idea. So if I go over to my wireframe tab here, you have the silhouette boundary that you're used to using, and a lot of people would use curve on all edges, but it would never support the 2D, 3D switch. So this is the enhanced selection tools I was talking about. So you have shift click for tangent faces, control click for matching fillets, double click to select a feature. If you have bosses or additional features on a part, it'll select all that are like that. And then now triple click is to select the entire body. But the additional functionality that this gains as well is I can go here in my quick masks on the right hand side, and I can say select all advanced, and I can go by color, and it now respects the solid face colors, which was not available before. So I can say select everything that's kind of that off green color, say OK, and now I can end my selection here, and I'm going to get some wireframe. So if I switch between my 2D and 3D button here at the bottom, it'll either swap right to the faces, or I can put it in 2D mode. It'll have my 2D height set here, and this is a metric file, so it's 50 millimeters above the part. But I then have two other options over here called only outside loops and ignore shared edges. And then I get more of a result that's similar to if I were to do a silhouette boundary. And so I think that could be very useful for a lot of people for creating containments, like I said, and any sort of control geometry in general, which we'll talk about that when we get into the 3D toolpaths a little later. So For creating letters, this is similar to how it was when we were doing the roll unroll command. So since we've moved letters into the panel interface, anything you type is now going to be live on the screen, and then you can place it wherever you want. And instead of having to go in and out of the command and undo, redo, you can really set exactly what you want as far as your letters to be and the location, and then get them exactly where you want on the part on the first try instead of kind of the guess and hope like it was before. We've also added some additional font support. So we've always supported true type fonts, but we also support open type fonts, which is anyone that's into that sort of stuff. Open type is a lot more user friendly than true type. So undo, redo. So with the model prep commands, we've had them now, I think, since X8. If you didn't get the result you wanted, you basically had to either have a previous version of the file or physically undo the command that you did. You know, say you added a radius to a part, you'd have to go back and undo that radius if you wanted to get rid of it by using like the push-pull command or one of the other commands in there. But it's actually under the solids tab in your managers on the left-hand side of your screen. And it's its own separate undo redo that can do up to 25 commands. The only thing you have to be mindful of is if you're switching between traditional solid modeling like an extrude or add a fillet or something like that, and then go back into model prep, it will, it's kind of two different modes or mindsets of how you're going to be solid modeling. So the undo redo will only work as if you stay in the model prep commands, and then you can undo redo. And this is separate from the undo redo that's at the top of Mastercam for like wireframe and things like that. And I also had someone ask me in one of the rollouts if they wanted to undo deleting of a toolpath. That's in the operations manager, and if you right click in there, there is an undo option in there. So if you accidentally delete it and even click through the little warning that says, hey, you're about to delete a toolpath, you can click undo there. So there's really 3 total undo areas now in Mastercam. Your main undo redo, then on the solids tab for the model prep, and then in the ops manager for toolpaths. So I don't really have an example for this, but it's another one that I recommend for you guys to check out. But we basically redid and moved it to the panel interface for all of our drafting commands. So it works kind of like how I was talking with the letters. You get better live previews. You can switch through whatever you want, and it's just a lot easier to get the drafting exactly the way you want it. And that leads into the final part of the drafting here, which is align note. Used to be a C hook, which it's now right on the drafting tab, and it works the same way like the drafting or the creating letters in that it's live, but it allows you to quickly get some documentation into the file without having to go through a bunch of extra menus via the C hooks. So that's all I had for the 2D, 3D mill. See if we have any questions, or not 2D, 3D mill, sorry, the design. But so we've covered the general system enhancements and all the design stuff, and we seem to be about right on schedule here. But I'll give it a second if anybody has any questions. I don't see any. So let's get moving into the toolpaths. So we now have additional support for inch and metric tools. And before Mastercam, you would have to convert a metric tool into the inch library and then bring it into Mastercam, or you'd have to create a tool and type in the metric value into an inch tool. But now you can basically open up any inch or metric tool library and have it pull right into Mastercam. So, and you'd also maybe notice if you did convert a tool from a metric to an inch library, you'd get a tool that was 25 times bigger than what it should be, even though you could swear you typed in the correct value. Well, that was something that we fixed in the software by adding kind of some of this back-end support for supporting inch and metric tools. So you'll get a lot better results if you have a mix, which a lot of the customers I've been going into lately, it seems like everybody now is using a mix of inch and metric tools. So it just adds for a little additional support to make your lives easier. And we added Analyze Toolpath back in 2017. So that's where if you go on the Analyze group on the Home tab, you could view the toolpath and it would show you, you know, what the position was, or if it's an arc move, like is it a GO2, GO3, stuff like that. But we've also now added the tool and holder display that was under the check holder command in 2017. So 2017, you could go into a particular toolpath, right click on the tool and say check projection, I believe. And now that works anytime when you're in the Analyze toolpath. So you can validate, you know, tool stick out and clearances. And you can also shift and click on the holder and adjust your stick out right there, and then it'll update on the holder page in your particular toolpath. And lastly, we also added multi-axis vector. So back before, if you're doing Analyze Toolpath, it would just give you the XYZ location of the tooltip or wherever you were comping the tool to. But now it'll also give you the angle vectors in a multi-axis toolpath. So chaining tolerance. Chaining tolerance before you would have to set in the configuration menu, and that would be kind of a pain if you were, you know, maybe trying to get around some bad geometry and you wanted to open up your tolerance for, say, a roughing toolpath, or like on turning, you made a turn profile and it was a really funky solid and you had to then clean up the wireframe. Well, now if you click on the geometry section of any toolpath, you can adjust the tolerance at the per toolpath level. So you still have your global tolerance. So that 0.001 that is on my screen there now, that's what I have my system config set to. But I can go into a particular toolpath, you know, if it's something that I'm leaving 100 thou of stock, I can bump up that tolerance to 50 thou and not have to worry about cleaning up geometry. So it just makes it a lot easier to adjust your tolerance throughout a part. And you know, the end goal with a lot of this stuff is having to create as little reference or construction geometry and editing geometry as possible so that you can get the toolpathing and getting the program onto the machine. So guided chaining. So back in, I believe, 2017, we added a option in the solid chaining called linked edges. But anyone that used that, if you had a really big solid where you needed to specify a specific chain, you know, you had to go through there and click each little entity. And anyone that's ever worked with a solid, if there's really small facets or something in there, you know, there might be 50 tiny little pieces you got to click on to get through a particular curve if it's a spline or similar. So let me show you a little bit how that works. So I got a standard part here. We got a couple examples that I'm going to be going through over the next couple of slides. But let's say I want to contour out the lower part of this face over here. And I can go into Toolpaths, Contour, and now I can go to my chaining, and this is where your linked edges option is right here. And I think the GoToMeeting for some reason is not showing my actual mouse cursor, so I apologize for that. But so I'll try to make sure I'm explaining everything I'm clicking on here. So I can go to linked edges and I can start to pick here and I can pick on this edge. Now you'll see these new arrows that'll pop up. So I got blue and then red. So that coordinates with how normal chaining works. So green is the start of my chain and red is the end. But what I can do here is if you see these two buttons that are new at the bottom, so I got next and adjust my direction, but if I keep clicking next, or I click on the X key, because if I hover over any command in Mastercam and there's an underscore under one of the letters, that's what the hotkey is for that command. So if I keep clicking X, it'll keep going around. Now you'll see when I get to here, my red arrow is pointing down, and maybe I want to switch that. So that's this other button here with the 3 arrows, and I can adjust it and flip it, because it's basically looking for the most tangent direction for it to go. But I can keep clicking next and, you know, say I want to contour it around to that point. I can say okay, and say, let's just say generate toolpath, it'll pick a default tool. But now I got that partial chain toolpath without having to, select on each individual entity. So I know that's kind of a basic example, but I think it'll give you guys a good idea on how you can use that function moving forward if you're working on solid files. But also if you're doing a partial chain in wireframe chaining, that option is available as well. So we've now added what's called associative linking inside of Mastercam. So on your standard linking parameters page, which is all of your Z heights, we now have a third option in here called associative. So what does that mean? It basically means I can assign any of these values to something that's on my screen. So I think the easiest way for this to make sense would be to show you guys inside of Mastercam on this file. And it looks like Josh says he can see my mouse. Okay, great, because it's not showing up on my audience view that I have up on a second monitor here, so I can make sure that the video is caught up. But so that's good. So let's say I have a clamp right here, and I have a toolpath here that's drilling these two holes that's avoiding this clamp. And so if I go into my parameters here, go to the linking parameters, now you'll see that my retract is set to, now this is again a metric file, but it's 1 millimeter above that particular clamp as my retract height, and it's set to associative. So if I click on select point, you'll see it does a little black and white dot to notify where that point is being pulled from. So if I go in here and let's say, the job changes or something happens and I need to adjust my work holding, and I'll take this clamp and move it up, let's say 10 mils. It's set to move. I can say OK. Now you'll see right away this toolpath gets marked dirty. And if I hit recalculate, it now is 1 millimeter. It's still 1 millimeter above that point of the top of the clamp I selected, but it's still relative to that clamp height. So again, if you missed it in the beginning, you can set any of these values now to that associative. So if you pick associative, you click this select point here, and then you can adjust where that associative point is based off of. And this is an example of where I was telling Mastercam as a future enhancement request was I'd like to see these values right on my graphics screen. So I got one of the interface managers at Mastercam investigating on how we can get basically these linking parameters on the graphics screen. So the next item on this particular file is stock awareness for drilling and other circle toolpaths inside of Mastercam. Any of you that sat in on our 5-axis for the 3-axis customer webinar, this does steal a little bit of thunder of that, but basically what it is Mastercam is basically letting some functionality that we've added in the 5-axis toolpaths down to our even 2D product. So basically what we can do now, as long as you're using a stock model, you can let the stock model determine what all your Z heights are for drilling routines. So let me show you how that works on this same file we've been working on here. So I have a drilling toolpath here. Now all I have selected are the particular drill points. So I have no Z heights determined or anything like that. It's doing whatever the default settings in Mastercam are for my depth and retracts for the particular points. But what I did here is I have, let's say, a casting model of what I want to start as my rough material, and that's on your toolpaths page, and you can say stock model, and then you could base the stock model really off of anything, but I'm basing it off of a solid model that's in there on this particular part. But I say stock model, base it off of a solid, say OK, and then that gets me to this point that I'm at now. So if I go into the drill toolpath and click on parameters, you'll have a new page here in the drilling or circle mill or any of those other circle paths called stock. So I click on use stock. What do I want to base the stock off of? Well, I only have one stock model in this particular file, so that's what I want to use. You can also use just the general stock setup in Mastercam. So if you don't want to take the time to make a stock model and say you're just working with a square piece of material as you're starting, you can use that as well. And then what do I want to use this stock for? Do I want to use it for my feed position or my depth as well? Well, for this example, let's use both. So once I turn that on, it again marks the toolpath dirty, and I say recalculate. And now you'll see that if I go to a front view, it adjusted my entry heights as well as my Z depths here based on that stock model. So if I turn that stock model on and turn this one on, you can see that all those drill heights are now correct for based on my particular stock. So even though that's again another basic example for the purpose of an event like this, but I think you guys can see the usefulness of that as long as you're defining your stock for a particular part. Sorry, my boss was distracting me there. So let's get into some more 2D toolpaths here. We've now added an option on the toolpath filter page, or the arc filter page that's near the bottom of the left-hand side of any mill toolpath. You know, a lot of people use that now to shorten up code or adjust certain parameters like that. But we now have a checkbox there for override arc feed rate. So, you know, if you're cutting on the ID of an arc, you maybe want to slow that down because you're having more radial engagement of the tool. But if you're on the outside of a part, you can maybe speed up your speeds and feeds because you have a much smaller contact point. So we've added that option in there, and it's a pretty small one, but it works for 2D contour, slot mill, and also on the 3D side, it works for any waterline toolpath. So we actually had one customer that used this on a waterline finishing for a mold and cut about 30 minutes off the cycle time, being able to rip a little bit faster on all the OD arcs. So we've added now as well depth cut order for the dynamic tool paths. This was another one that was a customer request. They were doing really thin wall parts and with a lot of different features, and they basically wanted to chain them all and do it all on a single tool path with the 2D dynamic mill, but they wanted to do each pocket individually before, or each depth cut individually instead of doing each pocket at once. So by default, dynamic mill it would do an entire feature and then move on to the next one. But you know, if you're working with a part that I have pictured there and you got real thin walls of aluminum, you don't necessarily want to hog out that entire pocket before you move to the next, because you know you're going to get deflection and other bad things like that. So we just added it to the depth cuts page on the dynamic mill toolpath, and you now have the option here for by region, which is going to do each pocket individually, or by depth, which will then move across each pocket you have currently programmed. So 2D contour overhaul, you know, you never thought that, you know, one of the big enhancements we do for a release is redoing how our 2D contour works. But another example of a lot of customer feedback, and a lot of us that have been using Mastercam a long time are just used to, you know, taking a contour op, copying it down, and adjusting some parameters so you can get kind of the second result you'd want from a given contour. So examples of that are, you know, we've added spring passes in there. We've adjusted on how it does the finish passes. So you can, you know, do a finish pass here at all depths, final depth, by number of rough cuts. How do you want to do the multi-passes? And I think I already said it, but the spring passes as well. So like I was doing a file for a customer over at an OEM, and yeah, I just had a bunch of copied operations because we were running spring passes to make sure that this thing was right on tolerance. And you can now add that right in a particular tool path. And this is a little more information on the spring passes, but we've added it to dynamic contour, peel, blend, regular contour, slot mill, and circle mill. So kind of any of the basic 2D tool paths, we've added that button in on both the finish pass and multi-pass page. So if I go over into Mastercam here, I have some examples on another file. There we go, multi-passes. So let's go into one of these tool paths here. If I go into my multi-passes page, you'll see that I have two finished passes at all depths, but I can adjust them to do it just at the final depth or by number of rough cuts. And then I have my spring passes here as well. And I had a couple people request at the end of the in-person rollouts, but if you guys want any of these example files, I have a link that I can send in a follow-up email to you. So just shoot me an email, matts@shopware.com, or one of our general boxes, and we can get you over these examples if you want to see what we did in some of them. But I just have a bunch of different examples in here on how those different settings work. And I found after doing this, I think this is the 4th time I've done this presentation after all of our in-person ones. But I think really the best way to kind of figure out what these new settings do is to just take a tool path and start seeing how these adjustments work. And especially if you work on dual screens now, we added this back in 2017, but there's a preview toolpath button. So I can adjust it and say I want to add, 5 spring passes. I can hit preview and then the toolpath will update, or maybe I only want to go down to 2 rough passes. So I can keep previewing what these settings do without having to hop in and out of the particular toolpath. So another one we added off of customer request was they wanted to plunge enter on a dynamic mill toolpath. So before, the bottom option there was only use custom entry chain, which had to have some sort of length to it. You couldn't do it off of a specific point. So a lot of people were saying, hey, I drill out a 1/2-inch hole before I start this rough routine because I don't want my 5 flute variable $200 end mill to do plunging routines. I'd rather just throw a cheapy drill in there, get it started to depth, and then let that expensive tool rip. So I have an example of this one as well. So I have a plunge entry here. So what's required to create that? So if I go on my levels here, I can draw any geometry I want. It can either be an arc or just a single point. And on my tool pass here, let's add it to this particular tool pass. So I have this one done already where it's plunging right in and then starts to dynamic mill out. Let's say we've already drilled out this hole on this particular part, and then we need to rough out this pocket. So on my geometry tab, you want to remember too that these tool paths are smart enough that as long as I have the machining region chained and then my entry region chained, it is based off of the closest entry point to the given area you want to machine. So you don't have to worry about what order you're picking stuff in if you have a lot of start holes and are doing a bunch of pockets in an example like this. So I can add a machining region here, and I can pick right off the solid, and let's do a loop. So that's the area I want to cut. Say OK. Here again is my chaining tolerance. That's by toolpath that we talked about before. And then I have my entry chain. So I can add a point here. Add that point. Say OK. And remember too, with any of the dynamic tool passes, we have this preview button. So it's going to give you based on, the default colors, black and red. Black and red is what I want to cut. Yellow is my containment, and blue is if I had an open pocket where the tool's free to move. But since these are interior pockets, I don't have that on this particular example. But now if I say recalculate, it will plunge right on those points. So if I go to backplot here, you'll see that tool will plunge right in to my set cutting depth and then start to dynamic mill from there. So that works with any of, this is the dynamic mill toolpath in the 2D section of the software. So the depth cuts page, and this kind of leads into the next example I have after this particular file, but we've added some additional undercut support, and I think that checkbox might have been there in 17, but Mastercam told me that they basically kind of rewrote the back end of that. So it supports a wider array of undercut tools. So really anything that has, and I'll show you guys this in the example, but anything that has geometry that's yellow in the tool manager on the top side is capable of an undercut. But we also added this to the circle mill toolpath, which I believe it wasn't there before. And we also have the depth cut direction, which is either step down or step up. So instead of boring you guys with more PowerPoint slides, let me just show you how this works. So I have a file here. I had sliced it in half just for demo purposes, so it's easier to see. But if I go into my parameters tab here, let's first look at what our tool requirements are. So if I double click on this particular tool, anything that has yellow geometry on the Z side of the tool is a tool that's capable of undercut. So if I were to create a new tool, it's going to be any tool that has geometry up there. So, a lollipop mill, a barrel mill to some extent, but also like a slot mill like I'm using here. And then on my depth cuts page, I have what my depth cut direction is. So since I'm doing an undercut, I want to step up, and I want it to detect the undercut. Because I can do a step up without an undercut, but I don't know why you'd want that. But I guess Mastercam wanted to leave that option open for you. And then the only other thing you want to be mindful of is your linking parameters are going to be in reverse. So your depth is going to be where the tool is going to start, and then your top of stock is where the tool path is going to finish. So how this is going to look in backplot is the tool will go down to that negative 0.3, and then it'll start to go around and cut upwards. And it has some additional support in here. So it does support tapers. So if you're doing an angled wall, and if you don't know an easy way to find out an angle, you can right click anywhere in the graphics screen, especially for those of you that are on X9 still. Right clicking anywhere in the graphics is going to give you all your entity attributes, which you can pin them to anywhere you want to get more, because X9 had all the attributes at the very bottom of the screen down here. But you can still pin these and move it down there if you want it up all the time. I found since it's under my right-click menu, I like to hide and show it as needed. But I can say Analyze Dynamic, pick on a face, and it'll give me what that angle is. So then I got my toolpath that'll then follow that particular taper. So that's all I had on the taper example. And then the last one I have for 2D here is chamfer. So anyone that started to use 2018, you'll notice that these chamfer boxes have slightly different names. And if you were programming directly off of a solid model, like the example I'll show here in a second, it was really hard to program the chamfer exactly the way you'd want it off the solid, because it wouldn't allow you a chamfer width of 0. You would have to put, 1/10 in there. I forgot how many zeros it'd let you go out to, but you had to have some sort of value as a chamfer width, or else it would yell at you and say, unable to calculate, or wouldn't let you move away from that screen until you did give it some sort of width. And then we've renamed the, instead of like the height of the chamfer, we now just have top offset and bottom offset. So top offset is the amount of distance that the tool is going to move from the chamfer from the beginning of the cutting edge. So, you want to make sure you don't wear out the same spot of that chamfer mill every time. So that top offset allows you to adjust the height of what that particular tool's going to do. And also, doing it this way can eliminate some guesswork, especially if you're programming directly off of a solid. So let me pull up that example here. So I have just kind of a standard bracket part here. If I go to, I believe it's a right view, I can get the side view here. But you'll notice my chamfer, if I do a translucent view and then right view, and I always got to remember, I got to wait for a GoToMeeting to catch up for me. But you'll see this chamfer is exactly where it needs to be. So it follows along, and I can program directly off the solid. But what you want to be mindful of as far as settings here, and before I get into the settings, what you want to select is if you're programming directly off of a solid, you want to make sure you pick the top chain of the modeled chamfer. If you're going off of a wireframe part, it's not going to have that chamfer modeled in there. So that's when that would technically be the bottom, and you'd use slightly different settings. But if I'm programming directly off of a solid on my cut parameters page here, I have 2D chamfer set. So that's where then this graphic shows up with the tool. But so I can set my chamfer width to 0. And then since this is a metric file, I'm a 1/2 mil away from the top of the cutting edge of that particular tool. So again, another small enhancement, but something that we probably didn't realize knew that needed to be changed, and we were all just used to it using Mastercam for a long time. And we're not doing a 5-minute break because we are doing this on a webinar, but that is all I had for the 2D toolpaths. And I had someone ask a question. Spring pass, same thing as what I call a pressure pass. Just runs a tool the same at the end again. And Josh, yeah, that's correct. A spring pass is basically going to run an identical motion to whatever the finish pass was for that tool path. So, accounting for maybe any tool deflection or just cleaning up to make sure that that part is size on size, you can run however many springs that you define in there. So, yeah, there might be some different nomenclature on how people name that particular feature, but yeah, it's doing an exact copy of whatever your finish pass is. So that's all I had for 2D. Now we're going to get into the 3D toolpaths, and it looks like we are at, I think, right about an hour. So I believe we're still on time here. So some enhancements to model selection. As we got more and more customers working with reverse engineered geometry, the short story on this is you can program an STL like you would a surface or a solid model now. Before, you'd either have to convert the STL or it was hard to select what you wanted to machine on the STL. Personally, I don't recommend programming off of an STL because it is triangular mesh. So you are going to get faceted depending on how accurate the STL is. But we have had requests where people want to do this directly off of there. And you have the same selection tools as you would now with like a surface or a solid model. So you can window select a particular set of faces on an STL and would work the same as how you've been used to programming a surface or a solid model. So the biggest change in the 3D toolpaths for 2018 is we've updated how the user interface works and how the workflow works when you're programming a 3D toolpath. And it's now a little bit more of a logical step through, and I think it's probably easiest if I just walk you guys through an example. So let's open up a 3D part here. It's a pretty complex steering wheel mold, but we'll stick with this simplified raster parallel type toolpath. But when I first go into selecting a 3D toolpath now, this is going to pop up right away. So many of you are used to seeing that smaller box that had drive, check, containment, start point, and so forth, depending on the toolpath. But now it's going to kick you into this window that, and especially for new users, it'll make a little more sense, drive and check, what is that exactly? But now it's called machining geometry, and avoidance geometry, which if you had never even seen Mastercam before, that makes sense to anyone that's in this line of work. So on the left-hand side here, you have anything you want to cut. So let's say I want to add to this particular group. I click the selection arrow here, and then it'll start to display what I have selected to cut. So I have this toolpath over here on the left-hand side, and I can escape out of it. And this is another one where having dual screens can help, because you can move this window over to the right half of your screen and being able to see what your different group colors are. And then I don't have any avoidance selected in this particular file, but that's the same as what check surfaces would be called in 2017 and prior. And so getting into a little more of the UI on here is you were used to seeing, you know, we've always had this where you can adjust your toolpath strategy kind of midstream, but before over here on the right hand side would be all your drive check geometry, containment geometry, and so forth. So now it's been all moved over here to the left hand side. So it's going to kick you first into your model geometry, saying, okay, what do I want to cut? What do I want to avoid? And now your next page here, we renamed it toolpath control. And that's where you have containment boundaries, how you want to contain it. Do you want to do inside, outside, which we're all used to seeing that. And it's basically all on one page now, where this was split between a couple. And after using this now for a while, I can't even remember how it was split up in 2017. But we're all just used to kind of hopping back and forth between the two screens to get the control of the toolpath exactly where we want it to. And start point has also been added to this particular spot. Then you select the tool you want to use, which we're all used to seeing this page. You got your holder page, which we're all used to seeing. And then you have your stock page. And one thing I forgot to mention on the model page, and this was kind of part of the reason the stock to leave tab was a little barren on 2017, is it's a feature we were trying to get ready for that, but we want to really make sure that it's ready for prime time, and that your stock to leave now is by group in here. So you have your wall stock and floor stock per selection group of what you want to cut or what you want to avoid. And after using this for a while, and I certainly invite you guys to give some feedback on this, as it's kind of the first iteration of moving to this new workflow for the 3D toolpaths. And I've already noticed a few areas where it can improve. You know, like let's say I want to propagate all my wall stocks to be the same amongst every machining group. There's no quick and easy way to do that right now. So I actually saw a preview. The 2019 alphas already coming out, and they're working on adding a selection down here to basically have a global stock based on what I'm selecting. But any feedback like that, you know, we're more than happy to take. So with that being said, since we are able to split these into different groups, I can adjust the amount of stock to leave on a particular group. So if I say, let's say I want to cut 10 thou deep on the right half of this, and this probably isn't the best example for it, but you know, say you're machining an electrode and you want to leave a little extra stock as it moves away towards the edge of the blend of the electrode, you can adjust that within the same toolpath, whereas before you'd have to split that up into multiple operations. So since I added, let's say 10 thou negative stock on the right half of this toolpath, it'll mark it dirty, and I can say recalculate. And then you'll see here, it might be kind of hard to see because it's only 10 thou, but I'll wait for GoToMeeting to catch up. But you'll see that that toolpath now will dip in a blended motion to account for that 10 thou negative stock to leave. And you can do positive as well. It also can help a lot if you have a lot of different check surfaces to, you know, you don't want the check surface to butt up directly to your drive surface, because the tool may not know exactly how far you want to stay away, because it knows it wants to avoid that surface, but how far. So you can, and I found this in real world practice, by adjusting that stock to leave on my avoidance geometry, which it's now called, I can get a little crisper tool motion, being able to split that up into groups depending on, you know, is it blending to a right angle corner? Is it blending to sort of a floor check surface, and so forth? But I definitely recommend you to start playing with how those settings work and adjusting the toolpath. So that's I have kind of some review slides of my example, but basically now you have your model geometry page, which is the first thing that'll pop up when you go to do a particular toolpath, and drive and check are replaced with machining and avoidance. You can adjust the colors to anything you want as these particular groups. If I were to double click like that green or orange, I can set it to whatever I want. But by default, green is machining and red is avoidance. So another 3D feature we added in here, and this is actually bringing back some old functionality based on customer request, is in X8 and prior, if you said follow containment, it took a literal approach to your containment boundary. So if the containment went off the surface or the solid of the particular model you were trying to cut, it would go all the way off and follow that containment boundary. Where in X9 in 2017, we kind of took more of a, quote unquote, high speed approach for that. So even if my containment boundary went off the model, it wanted to eliminate the amount of air cutting I was doing. And let me pull up the example I have for this one, which is the part you saw in the screenshot there. So I have two examples here. This is the X9 and 2017 functionality. And really the feedback was this is if you have an older machine that has a little bit of, it's not the fastest to accelerate and decelerate, you may get some bad results if the tool is doing a quick motion right away, exiting the material, trying to get to that next climb cut. So we now have the option to do it both in the prior X8 and before, as well as you can maintain the previous functionality in X9 in 2017. So on any 3D toolpath, it's going to be under your cut parameters. And if you expand that box, it will be on the steep shallow page. And you have just the option here to, do I want to follow the containment literally, or do I want it to just jump to the next surface? So if I leave it unchecked, that would be my X9 in 2017 functionality, and checked would leave it as the X8 and prior functionality, where it actually moves off the part and follows whatever containment boundary you wanted to create. So hybrid smoothing, one of the feedback we got from hybrid. So hybrid is a combination of scallop, waterline, and a raster toolpath all in one. So as we enhance this toolpath, we want to get it as close as possible to be able to be kind of a one-stop shop for your 3D finishing toolpaths. And there's a feature we've had in there for a while for flats and ignore flats, which I find very handy. So, you're not spending time finishing the floor of a part with a ball nose end mill, where you can go back and say flats only with like a bull nose or even a flat end mill and get that cleaned up. But two things we did notice in the hybrid toolpath were, A, when it is doing the scallop type motion, it wasn't smooth as it could be between passes. And then when it was in a waterline type toolpath, the transitions of the waterline were not as clean as it would be if you were doing just a waterline by itself. So let me show you guys an example of this. And let me turn off my retracts. So this is without the smoothing and how the output would be in 17 or X9. So you see when I'm in the scallop motion here at the top, I have very sharp transitions between the direction of the cut. So I get, you're going to get witness marks there, or, depending on your surface finish tolerances, how you want that surface finish to look. So your polisher isn't mad at you. And then if I get over here into the waterline motion, you can see that I have some kind of sharp points between these passes, and it looks like that should show up pretty well for you guys on your screen. But you can see it almost looks like a wave sort of pattern, whereas if I was to do this with a regular waterline toolpath by itself, it would be a lot smoother. So if I go into my parameters here on the cut parameters page, we now have this smoothing area over here to the right. So these are some of the functionality I was talking about before. You know, you have your flat detection if you want to include or ignore flats, which I think a lot of people don't know about in the hybrid toolpath. But the smoothing here, the default values is 165 degrees. So that's the angle at which the scallop motion is going to smooth itself. So think of that real sharp section here at the top. You know, that's way less than 165. So it's only going to smooth it out between that angle and below. So I've tried to mess with this to see what sort of output is best, and trying really 5-degree increments from 0 to 180. Really between 165 and 175 is the sweet spot on how this function works. I was even telling Mastercam they could probably just have a checkbox for smoothing and leave it on or off. But the blend distance does have some value. So the blend distance is going to determine those little waves we saw with the waterline toolpath on how often it's going to try to smooth those out. So at 20 thou here, if I display the toolpath, you'll see that I have nice smooth transitions in the scallop motion. So it's a nice rounded arc move. And if I have my arc filter turned on, I can ensure that the code doesn't get too long. And then over here in the waterline motion, you'll see that all those kind of peaks and valleys got smoothed out into smooth tool motion. And, you know, depending on the size of the part and the type of finish requirements, I would look into adjusting this. I found anywhere between about 5 thou and 50 thou is a good range to kind of start playing with. I found anything bigger than that, it'll try to straighten out the toolpath too much and won't get close enough for a particular surface finish. And if you guys don't know, the arc filter page then would be down here. If you do turn that smoothing on and realize the program got a lot longer, say there's a lot of scallop motion in that particular hybrid toolpath, always be mindful of, you can set your total tolerance, turn on filtering, and then depending on what your tolerance of a given part was. And I had a lot of questions on this at the in-person rollouts, but the easiest way to explain this is I would probably set this to at or below what my tolerance is for the part. So let's say this particular part is my customer saying it's plus or minus a thou for a given finish. And then over here is my cut tolerance is how closely it's going to follow the given geometry I have selected to cut. And then my line arc tolerance is how often it's going to try to create arcs based off of the given tolerance. So a good starting point is if I'm doing a roughing toolpath, I'll do it 50-50. So it gives me a little more tolerance for it to create arcs and shorten up the toolpath. Whereas if I'm doing a finish toolpath, I'll move it more to like 80 or 90 for cut tolerance, because then I can get a little more accurate of a toolpath, but I will get a little bit longer of code. And then the last thing is, since I was talking about the undercut support on the 2D contour, since that's kind of in the background database of Mastercam, the surface finish contour, which is kind of a classic toolpath but still has a lot of use in Mastercam, its undercut support is drastically improved for 2018. So if you do have a part that has, say you're using a lollipop cutter and you need to 3D undercut a surface, it's going to calculate a lot faster and basically allows for the better support of the given style of tool to get the correct motion that you want. And I had an example here, and I don't have it in the webinar, but I had a part for a customer I did a couple of years ago and threw it into 2018 as kind of a test. And the toolpath calculated in about 30 seconds in 2018, where it was closer to 5 minutes back in X9 when I did it originally. So that's all I had as default material for this, and it is 11:15, so I'm about right at the 75 minutes I said this would take. but I have nothing until lunchtime. So if anyone has any questions or wants to go over any examples in particular, I'd be happy to cover it. And also I have the PS there. Please send us your ideas and feedback on 2018. You can send them to tech@shopwareinc.com.